most of these, like we said, were review, correct? From Mr. Adams. And just to brush up, today we're going to do compound inequalities. Okay. Um, and then we will practice. Tomorrow we're going to get into graphing. And then we go beyond what Mr. Adam taught you because we get into, did you do standard form with Mr. Adam? When X and Y are on the same side? We'll do that. And then you just did slope intercept form. Okay. So we will be learning new things then tomorrow. I'll do a quick review of the slope intercept form and then we'll be learning about standard form. Okay, any questions on that? Okay, so 91 equals negative 7 parenthesis x minus 6. We have to always do what first? Distribute it. Minus 7. Very good. So I'm going to distribute negative 7 to x and negative 7 to minus 6. Now, a common mistake is when you take a negative and you multiply by a negative here, a lot of students don't change that to positive. So we need to change that to positive. So we get 91 is equal to negative 7x plus 42. Now, I'm going to go ahead now. This is a two-step equation. I don't have to combine like terms. So I'm going to go minus 42, minus 42. If you don't have your own calculator, please get one off the wall instead of using your phone. And so we get 91. 91 minus 42. And that is 49 equals negative 7x. You're going to divide by negative 7 on both sides. X is equal to negative 7. Any questions on that? No? Okay, so now we're going to go to the next one, right? And we do have distributive property again. So we're going to take a negative 8 multiplied by negative 7, negative 8 multiplied by 4a. So what a negative 8 times a negative 6 is a positive 48 minus 32a is equal to 12 plus 4a. I'm going to go ahead and draw my line here. I need to get variables to one side, constants to the other. When it's just equal, I like to keep my variables positive. So I'm going to add 32a to both sides. And you always deal with the variables first. If you don't have a paper, you didn't pick it up when you walked into the room. It's on the bottom of those bins right there. So make sure you grab one. Okay. I just told you where it's at. It's over there in the bottom bin. Every time anybody walks in, they go get the bottom paper. There we go. Anybody else? And if you need a calculator, it's on the wall. So don't sit down yet. Don't sit down yet. Don't sit down yet. She sat down. Ma'am, you need a calculator. There should be some on the bottom too. If there's not, I have a couple extra by me. there any more on the bottom there? There you go. Okay, we good? Oh, for these, please give them back to me because I use these for a specific thing in geometry. So hand those to me. Don't put them in there. Di, do you have your own calculator? Not a phone. No phone. Oh, do you get migraines? Okay. So I'm going to put 12 here plus 36A. So I got interrupted with that one, and that may have been hard for those who are trying to concentrate, so I'm going to just explain again. Please remember, class does not start at 1. Class starts at 12:50, right? 12:50. So it started 10 minutes ago. So try and get here on time. So -8 times -6, positive 48. -8 times positive 4a, negative 32a. 12 and 4a come straight down. I need to get my variables to one side. So I'm adding 32a to both sides here. The 32 cancels here. I'm left with 48. 32a plus 4a is 36a, and then I have the 12, right? Now this is just a two-step equation. I'm going to subtract 12 on both sides. So then I get 36 is equal to 36a, and then you divide by 36. So all that work, and a is just 1, right? Now, I said that I had video recordings, and I did send them. Synergy is not sending them to email for some reason. So I'm updating my Google Classroom, but that takes time because I wasn't expecting to have to do that since it all worked fine last term. So you'd have to give me a little grace. I shall have a um, Google Classroom fully updated, hopefully soon. And then if you need to review any of these videos, you can. Okay, over here, I'm going to take -3 times 8, -3 times a -2p. So you always do distributive property first. 6p minus 17 is equal to -24 and plus 6p. Negative times negative is positive. So now I'm going to deal with the variables first. I subtract 6p on both sides. Oh no! What happens to the variables? They crossed out, they fell out. And I get -17 is equal to -24. I can't just give that as an answer. Somebody said it over here. Who said it? Say it loud. No solution. That's right. When the variables fall out and the numbers that are set equal to each other are different, then this is no solution. However, if the variables fall out and the numbers are exactly the same, then what do we say? All real numbers. Because any number would work in that case. In this case, no matter what you choose for P, there is no value for P that can make this work. So you all remember no solutions? Good. Good. And everybody needs to sign in because I don't have everyone's name, right? Hopefully everybody signed in. Okay, so over here, I have distributed property again. Negative 6 times negative 7n is what? 42n. And then negative 6 times 7 is minus 42. Greater than or equal to negative 37.8. Now, this is a two-step equation, but it's an inequality, right? Because this says greater than or equal to. When you have inequalities, if you have to multiply or divide across an inequality by a negative number, what do? We change the direction or flip that inequality around, right? Now, if I'm dividing by a positive number, do I do that? No. And if I have greater than or equal to or less than or equal to, it is a closed circle because I'm including that number because of or equal to. However, if there is no mark under there, then I'm not including the number that I end up solving for. So it is an open circle. This one does not get included in the answer set, right? Make sense? There's a chair over here. Somebody may have to move a backpack. Is there any? There's a chair over here. And we still have a couple. There's a chair there if you want to move the wicker basket and just sit there too. I do that on purpose because there's so many of us. Okay, add 42 to both sides here. This cancels. 42n is greater than or equal to 336, and then I divide by 42. I do not flip that inequality because n, or this coefficient in front of n, is positive. So n is greater than or equal to negative 8. And I come up here, I find negative 8. I'm going to do a closed circle. And greater than means that I'm heading in this direction, right? Good. Now over here, I'm going to do this. First, I have to distribute. And then I'm going to have to combine my like terms. So, negative 8n, negative 24, negative 3n, greater than negative 3n plus 24. And on this side, I'm going to combine my like terms. Negative 11n minus 24 greater than negative 3n plus 24. I'm going to add 3n to both sides. That would be what? 8, negative 8n minus 24 greater than 24. I'm going to add 24 to both sides. Negative 8n is greater than 48. Now I'm dividing by a negative. Uh-oh. I have to flip here, right? Yes. Alarm bells should pop in your head every time that happens. So n, change that direction, right? Negative 6. And then I come up here, I go to negative 6. Is this going to be open or closed circle? Open circle. And I'm heading less than. All the numbers are getting more and more negative because that would make it less. Okay. We have one more. We have 3p minus 4 times the quantity 8 minus p less than 7p minus 37. When I have this minus sign right here. I have to be careful because that makes that 4 negative. So I need to multiply to the 8 and then multiply to that minus p. So I get 3p negative 32 positive 4p. Nice. Less than 7p minus 37. Very nice. Okay. I'm going to scroll this up because some people in the back may not be able to see as well. There. I need to combine my like terms first. Right. The p's are my like terms. So 7p minus 32. 7p minus 37. I'm going to subtract 7p. Oh no, what happened to the p's? That's a no solution. Oh, yes, it's a no solution. And it's a no solution because this is untrue, right? Now, if this was flipped around, if it was greater than, then I'd say all real numbers, because then it would be true. But in this case, this is no solution. And if it's no solution, you don't graph. How do we feel? We're going to do well on tests when we have it. It'll be next week, right? Tomorrow we're going to go learn. We're going to do some graphing. Okay. So now today we're going to do a little bit more. Did everybody sign in? Did you sign in? Yeah. Okay, good. Everybody here sign in? Okay, so today, let's see, am I on schedule? Oh, almost. I'm actually a little bit early, 12:50 to 1:20. Do now. Okay, so we're going to be going over this compound inequality lesson, which means we have and or statements. We then will have some practice. If you get done early with your practice, just turn it in and you're free to leave. If you need more help, let me know and we'll have to schedule a time to get together, okay? Okay, graphing and solving compound inequalities. Students will be able to graph and solve and or statements of compound inequalities, including special cases 80% of the time. Now remember, we are not going to do Venn diagrams, but unions combine all solutions of a set. For example, if I have set A, 1, 2, 3, 4, and set B, -4, comma, -6, the union would be all of those numbers, right? So what would be the union of this one? 9, 10, 11, and -2 and -4. Usually you write these in increasing order. So basically, from least to greatest, and you don't repeat numbers if there is one that's repeated. So I would do -4, I would do -2, and then just, oh, 9, I almost skipped 9, 10, and 11, right? Okay, so same thing here. What's the smallest number? 0. Do I write 2 zeros? Just 1 0, right? Even though I have a 0 here and a 0 here, the union, I only write one of them. And then I go to 2, and then what? 3, 4, 6, and 12. And again, there were 2 6s, but I only wrote them once. And so then the union of this would be -4. No, -4. -4 is smaller. Now -2, 0, 1, 2. The more negative you are, the less you have. Because that'd be like you owe $4 instead of owing $2. So you're in the hole more. Any questions on union? Union just means you combine them all together. So, like a recipe and a cake, you combine everything. You're going to put your eggs, your flour, your milk, everything together. Okay, so intersections are a solutions are the solution set that they have in common. So in common means they're in both. So if I look here, 7 isn't in that one, so that isn't an intersection. 8 isn't over here, but 9 is here and 9 is here, right? And 10 is here and 10 is here. Is 11 over here? No. So no 12. So there is only 2 numbers that were in both, 9 and 10. And that's called an intersection. So intersections are when are numbers they have in common, right? So over here, find the intersection of each set. So I have A and B. Does A has -1? Does B have -1? 0. No. 1. No. 2 and 3. Those are so 2 and 3 are the only 2 numbers that they have in common. So what about this one? I have 4 and 4 and then 8 and 8. Very good. So 4 and 8. I do not do very pretty brackets. Did Mr. Adam do pretty brackets? No, his was just as ugly. Okay, no, I don't feel as bad. Um, let's see. 20, 30, and 40. Are say 20's here and 20's here, 30's here, 30's here, 40's here, 40's here. So 20, 30, and 40. Questions? We know the difference between this won't be on my test. Okay, I'm not going to put Venn diagrams on the test, but I needed to explain them because now we're going to compound inequalities. Because it turns out ors are unions and ands are intersections. That's not me, is it? Okay. Okay, so compound inequality solutions for two sets of inequalities. Statements include solutions that solve either one of the statements or the other statement. It is a union, so we're combining both as your answer set, right? I have an extra one? So here, when I graph x is less than -5, I'm going this way. If I'm graphing x is greater than -2, I'm going this way. Any one of these numbers on this number line that's shaded is a solution because or can be for either one. Okay? Now, um, this one, watch here. X is less than, or no, greater than 4. So I'm going this way, right? But then X is less than or equal to 7. I'm going this way. The whole thing is shaded, right? So we call that infinite solutions because it covered the whole number line. And so we really wouldn't even need those circles anymore. It would just be an infinite solution like that because they overlapped. Does that make sense? Okay, so go ahead. Well, right, in this case, because it included every single number. And that's only when it's an or. Okay? Now, so we're going to practice graphing ors. Want everybody go ahead and practice. Check with people at your table. I will walk around and help you if you need help. Okay? So you're graphing both on the same number line. I'm missing somebody sign in, or did they sign in on the back? I only have 26. I think there were 20 or 27. Did someone sign in? If you don't sign in, I can't put in your attendance. Everybody signed in? How come I counted? Did I miscount? Miscount? No, that's yes, please. Yes. Mhm. Good. I was awesome. Oh, that this afternoon. than 5 would be this way. Less, that's just kind of all I was. So it would be from here all the way over as a solution. Now, yes, you just go all the way through. Yeah. These are not these are all ors. We haven't got to the end yet. Yes, so it's gonna be one line that just goes this way, because it's everything. So think about this being here, and it's gonna go. Oh, sure. Okay, so let's go over, because I had some questions. So this one was okay, right? Open circle, because there's no line under it, and I'm heading in this direction. And then this one, I'm at 10, open circle, and I'm heading this way, right? Okay, that one was pretty easy. It's this one, everybody's like, what? Huh? Okay, so let's look at this one. So it is less than or greater than 5. Close circle here, and I'm heading this way, right? Okay, and then this 8, I'm going to switch colors just so you can see what's going on. This 8 is open, and it's going in the same direction. But remember, it's a union, right? So it's just all of this. It's just gonna be one long line from here, because it's what they share, or right, because it's an or statement. Make sense? Tricked you. Didn't mean to. Okay, so A is greater than 0. So here's 0, open circle, greater than, right? And then I'm going to switch this. Less than 7. Did you have this way? Everybody good? Okay. Now what about this one? K is greater than 8. So here's 8 and greater than. And then less than or equal to 7. Oh, close. Do you know what this actually is? Yeah, it includes everything but one number. It includes everything but 8. Right? It's actually every single number out there except for 8. Well, yeah, that's true. Okay. Any questions? Well, I guess anything in between 7 and 8 wouldn't work either. So, like 7.5 would not be a solution, right? 7.9 would not be a solution. 8 is not a solution, but 8.1 is. Okay. So now let's talk about and statements. And statements have to be able to be solved for both. Okay? So they have to overlap. And we're looking for what they have in common. And statements are unions. Okay? So if I say here, I'm greater than 5 and less than -2, greater than -5, sorry about that. It's just going to be in between there, because it has to be true for both. And so like if I just choose one, -4. Is -4 greater than -5? Yes. Is -4 less than -2? Yes. So I'm good. But if I chose like -6, -6 is less than -2, but it's not greater than -5. So that's why -6 is not included in the solution set. Because for an and statement, it has to work for both. Okay, got that? Now, since intersection, the only solutions are numbers greater than, I don't know, I didn't grade. Okay, so this is, again, one of those that I'm going to have two of them. So I have this one for this, and then if I graphed it just so you could see it, it'd be like this, but I'm looking for the overlap, correct? Well, the only ones that they would have in common would be from this statement over. It wouldn't include any of these because these only work for this one. It won't work for this one. So that's why only this one is the answer, because they have to have an overlap. It would be from here and on, that's the overlap. So I can't include any of that. Does that make sense? Look at it carefully, because I care 6. Right, it's not overlapping. Okay, got it? Everybody? You bored? Harley, are you bored? I'm not trying. If you get bored, I put challenge problems up there. Look at, turn. If you get bored, if I'm not challenging you, okay. So, oh, I forgot about what a tornado drill. Okay, so a tornado drill is we close the door. I believe do we have to turn off? I believe we turn off the light, and we're supposed to get under our desks. I'm not gonna make them. You might have to, but we just just close. You get away from the windows, so like you would all have to move over to here. So just make sure you're not near a window. Yes, you can get under a desk if you want to. So yes, you are supposed to get under. Are we supposed to get under the tables? Okay. She's saying she saw you under the tables, so we're good. You can get out of the chair. But if it was a real tornado, you'd want to get closer to the bottom. You'd want to probably have something over your head just to protect yourself. You'd even want to sometimes like go like this. I was in my closet what was it, a couple weeks ago. Was anybody else like in their basement or a closet because of all the tornado drills? Yeah, I was. You were sitting. See, I lived in Arkansas. We learned you do not mess with tornadoes because people. Yeah, just go ahead and sit. We're going to continue. Um, so it's for two sets of inequalities. So look at this one. It's saying greater than or equal to -5, and x is less than or equal to -5. There's only one number that this would work for, and that'd be -5. Because if I graph this one would be going this way, right? The other one would be going this way. Where's the overlap? Just that number of -5. Okay, but that's this one. Since this is an intersection, there's no solutions that satisfy both equations. So this one, if x is greater than 6, if I'm going this way, and then I'm at -2, and I'm going this way, is there any overlaps? There's no overlaps. No overlap. So it's a no solution. So when you gave me this answer, you'd have to erase that. That's why we do things in pencil, or be smart and get erasable pens like I have here. Makes sense or doesn't make sense? Graph and the following and statements. Remember, you want to see the overlaps. You may be erasing. Then, if you need an eraser, I have some pencil top erasers. Um, so make sure you don't do these in pen. This would not be a good one to do in pen. You're all clear. So glad you said something. So this first one is the intersection, right? The second one is a no solution because they did not have an intersection. So this one's written differently. This one is written as an and statement, and it means in between. When it's written like this, it means in between the two numbers. So at -7, that would be open circle. At 0, this would be open circle. This is saying b is greater than -7, right? But less than 0. Greater than and less than is the in between. Okay? He knew how to do these. He didn't understand those. Okay, let's look at this one. This is another in between. So if I'm at a -10 and this is closed, and then I'm at a -9, boy, I didn't give us much room here. And then it'd have to be in between. So it should look like this if you can't see it, in between the 9, -10 and -9. Okay? Yes? But of course, we have to actually solve them, right? We're not just graphing, we're solving and graphing. So over here, this is an and statement. When it's written like this, it's always and, which means intersection. Sorry, or they could just put an and. So here, I want to get x just in the middle. So to do that, I'm going to subtract 6, but you subtract 6 on all sides here. So I'm going to subtract 6 at the -19. I subtract 6 with the 6 just to get the variable isolated, and I subtract a 6 here. What is a -19 minus 6? -25. Oh, that's just 0. Sorry. 6 minus 6 is 0. So then I just have the 5x. And 36 minus 6 is 30. Excellent. Now I'm going to go ahead and divide everything by 5. I get -5x and 6. So x has to be in between -5 and 6 because it's an and statement. So -5 open circle. I go to 6 open circle, and it's in between. Now over here, I'm going to have to solve 2 separate problems and then graph it, right? So I would subtract 10, subtract 10. I get -8x is less than or equal to 72. I'm dividing by a -8. Uh-oh. Yes, I agree -9. I agree x. What do I have to do here? And why am I flipping? Because I divided by a negative, right? Okay, now over here, I'm just going to draw a line just to partition it off. I need to subtract 7. So -9x greater than or equal to -36. Divide by -9. Uh-oh, I'm dividing by -9. I need to put that inequality. So this is x and this is 4. So it's an and, so I'm looking for the intersection. So 9, negative 9 is here, and I'm greater than, so I would be going this way, right? And then 4 is here, but then I'm going this way. So it's going to be in between these two numbers. So negative 9, close circle, and then open at 4, and then through here. Oh, it's closed. Why did I say open? Thank you. Okay, so this one I said is a little trickier, right? Who caught my error? I heard two voices. Who said no, close? Somebody here. Her? Is it you two? Somebody back here said it. Said it. Said close. Somebody said close. Okay. So I'm going to be over here, right? And I'm going to add 6. I'm going to add 6 here. I'm going to add 6 here. And I'm going to add 6 here. What is a negative 14 plus 6? Negative 8. 4n. What's a negative 34 plus 6? 28. And then I'm going to divide everything by 4. So I'm saying n, right? And I have negative 2. And then I have negative 7. Can I be, oh, that's just this, oh, yes, right there, like that, okay. So I have to be less than negative 7, right? And then I'm going to be greater than negative 2. So less than negative 7 would be this way. And that would be open circle. And then greater than negative, uh-oh. This is like the one we had in our problem, right? Because it has to be and statement. So I'm looking for an overlap. Is there an overlap? Or did I do this one? Oh, less, yeah, less than negative 7, greater than negative 2. That's a what? What am I going to write right here? No solution. There's nothing that would make it true for both. Right? Because there was no overlap. Makes sense or doesn't make sense? Negative 2 is close. Yeah. I was more looking at the overlaps. But either way, it's what? No solution, so it didn't matter because there is nothing that would work for both. In fact, we really wouldn't even have this on here technically if you were doing this on the Ivy Tech computer, because that's where he was at. You could like graph it like I did, but then you'd notice, oh, this wouldn't work. You would have to erase the graph and put no solution. Or it would be multiple choice. Only for graphing, you really want to try and keep it on the left side for your variable. It's just for graphing. For solving equations, it doesn't matter. I usually just try and keep my variables positive. Yeah. Okay, so ors are unions, right? So right here, again, we would subtract 9, subtract 9. 50p is greater than or equal to 50. We would divide by 5. P should be greater than or equal to 10. That's this side. Over here, -8, -8, -5. P is greater than what? 5. Divide by -5. Uh-oh. Flip the inequality. That would be -1. So this is going to be, and this is unions. So unions mean it doesn't have to overlap, right? It could be, as long as it's true for one, I'm good. So greater than 10, greater than or equal to 10, but less than -1. So that would be the graph for that one. This one is a solution because now we are doing or statements. And or are unions. So as long as it could be solved for one, we're in good shape. So this one has all these solutions. The only ones that wouldn't work would be this in between are the only ones that cannot work for both of, or for one of them. You just need for one for this to work. So this is the correct answer for this one. Okay? Over here, I just do the same thing. I'm going to add 1 to both sides. I get 6v is greater than -54. I divide by 6. V is greater than -9, right? Over here, I'm going to do the other problem. Add 6, add 6. 7v is less than -21. Divide by 7, divide by 7. V is less than -3. And this one, I don't care about intersections. It's just, as long as it's good for one, it's good for, it's a solution. So I go to -9. Oh, why isn't there a -9 on there? Why not? Did I copy and paste the wrong? Okay. -9. And of course, it's greater than. So open, going this way, right? Oh, greater than, greater than. And then V is less than -3. So it's going to be open and going this way. Okay, but this keeps going, right? And this keeps going. This would be all real numbers. Because it's going to include the whole line. Because if this is going this way, and this one's going this way, it just makes a big long line. So the correct way you would see this would be just a big long line. You wouldn't even need any circles. Because because it included the whole, it included the whole thing. Okay? Okay, so you get to try this one. Yes, because or includes everything. And since this one keeps going this way, and this one keeps going this way, there's an overlap. So it's all real numbers. Okay? I'm not sure. I must have like copy and pasted the wrong one. Just come over here and you can draw a new line, or I'll draw a new line on here. Yeah, there wasn't a negative on the. So I'm gonna go ahead and do it up here. Sorry about that. Okay. So when you solve this, I added 7b less than negative 35, divide by 7, divide by 7, b is less than negative 5. But there's no negatives. Oops, sorry. We're gonna solve this one and we'll draw a new number line. So 4b, so I'm gonna add 3, and we get 4b, 40, and then we divide by 4. B is less than 10. So if I'm going to draw a number line. Actually, I haven't. I can actually draw this a little neater. I forgot. I'm on this one. This has little wee. Right? There we go. So I'm just going to call this 0 here, and somewhere around here 10, and somewhere around here -5. Okay? And then so it's going to be less than -5, and that'd be open, and it'd be this way. And then it's less than 10. That's why there is no -5, because guess what? This is the actual just full answer because it included this. That's why you didn't see the -5. Right? Because they were going in the same direction. And since it's a union, right, I just included all. Did that make better sense? Good. Okay. So I'm going to go ahead and give you these. The answers are on the back for you to check your work. Feel free to work together. Okay. This ends at 2:20. So, and chances are you may not have enough time to finish. So you can take it home. It'll be due tomorrow. Okay. Turn in tomorrow. Finish that. And then I wish I had a magic and then I would go and it all be great as my one because you can raise since it's been pretty chaotic. I asked them to raise, but I do have a life. So I will try to get them. That's your homework. No, you do not have to turn that one in. We're working on this right now. You can hand it in to, you can take it out for homework if you don't finish it. Yeah, that's your school time. Well, I didn't do it. I'm gonna say and do it to myself. And, well, I hope everybody stays at least at 2:20, I don't know where everybody's going. What? You gotta go with it. Did you get this? No, you keep that. Turn this in tomorrow. Okay. That's homework. Make sure, but yeah, about 15 minutes to get it started. Give it to me tomorrow. Yeah, because I don't think you'll have enough time to finish today, right? Because I only have like 15 minutes left. I would start it because I'm here. I'm not at your home and I can answer questions. So if you ever are absent, I always throw the extras in here. And so this is what you have. Let's see if I, you know, I wonder if I do no. Right with my extra ones. The variables on both sides. I may have to print that one out for you. Let me print out the notes for you. Okay, so sorry.